How's it going, guys? And today we have kind of an unorthodox video. We are going to be covering how to spawn custom structures in your world. So if you do F3G, you can see the boundaries of the chunks, and we are going to try and work within these chunks. So let me go to the very boundary, very edge, and you can see what the coordinates are. 0, 4, 0. Okay, and it extends to infinity. This, I'm using F3G, by the way, or function plus F3G, fn plus F3G. That's what I have to do. It's just a debug system. Anyways, so this next chunk is located at 16, 16, 4. So you're going to find something pretty consistent, that every chunk is 16 blocks or 16 blocks wide, starting at 0, and every value of 16 going forward is going to be another chunk that you're in the corner of. So this is going to lead us to how do we come up with some kind of method to calculate where the corner of the chunk is, because what we want to do is find the corner of the chunk, spawn a structure inside that chunk, because if you don't go chunk by chunk, if you're not lined up perfectly, then you could have issues of your structure being halfway inside a desert and halfway inside a river biome or something like that. So you want to be lined up with the chunks because that's how the game generates. So let's go ahead and take a look at this. I have some extra stuff in here because I was just messing around, but we don't actually need tags, and we don't need advancements. We just need functions, and we don't need that, and we just need these. Okay, so we want to create a function that will help us locate when we are in the corner of the chunk. So we're going to just make a separate function and call that chunk align. Okay, so we're going to run a function that will get us to the corner of the chunk, and it'll just put a block down in that corner. And it needs to happen at whatever entity you execute it at, player, whatever. Wherever you are at, it aligns it to the corner. And this is actually a pretty simple, common coding problem that comes up, especially when you're making games, is aligning to some kind of tile set. So we're going to need to do scoreboard objectives add x dummy. So when you're making a data pack that you want other people to install, you obviously don't want to use XYZ. You probably want to use other stuff. I'll just call this, let's call this math. A lot of times math is a pretty common one, and I like to use math because you don't need to have separate scoreboards for this situation. I guess for the simplicity of this, I'll call it chords. Who cares? Anyways, you need some kind of scoreboard. So now on this scoreboard, we're going to save some temporary values that don't get used anywhere else, which makes it totally consistent. So we basically need to do execute store result. If you don't know what this is based off of, store result, I have a tutorial on it. I have a tutorial on almost everything I talk about. So store result score x chords run data get entity at s pause at 0. So what this will do is it'll grab my whatever this entity's position, and the position at 0 is going to be the x coordinate, and it's going to store it on x chords. All right, so now we're going to do that for y and z. Arrays start counting at 0, if you didn't know that. So 0 will be the first element, 1, and 2 is the third element. So x, y, z. So we have x, y, z. So let's say that our x, y, z is 6 and 4. So we need to figure out, or let's do a more complicated situation, because you could just use some arbitrary annoying logic here. Anyways, we're at 22 and 11. We want to get to this one, which is 16 and 0. How do we do that? There is a cool math equation or function called the modulo percent. And if you've ever been to elementary school, you actually already did modulo. That's why we do elementary school. So if you do scoreboard players operations x percent, oh, we actually don't need y. Sorry about that, because chunks are vertical. Percent equals hashtag chords percent equals hashtag 16 constant. All right. So scoreboard players operations scoreboard. Did I type this wrong? Scoreboard players operation And that's probably the correct thing. My syntax highlighter is sometimes stupid. All right, cool. So that's the right thing. It's just telling me it's wrong. So now we go Z. So what the modulo is, I'll briefly go over it, is if I take 11, right, and I divide it by 4. Well, in elementary school, this would not be, I mean, maybe if you're above elementary school, you would say that's like 2 point something something something. But in elementary school, you can say 4 goes into 11 2 times with a remainder of how many left. So 2 times 4 is 8. 8 plus 3 is 11, so your remainder is 3. And modulo basically just says, do this math, and your output is going to be this. So what we need to do is, if we do this, our output is going to be how high above the value we are. So instead, we need to save this value somewhere else. So scoreboard players operation, hashtag, we'll use an invisible player using the hashtag symbol in front of it, hashtag x chords equals x chords, okay? And then we'll do the same for Z. So then we just do it to these guys. So what this will do is it'll save, we'll keep the values on X and Z, they're safe, and we're going to put them somewhere else, do some math to them, and now we need to, so if our remainder is 3, then if we subtract the remainder from it, when we do % equals 16, then we're going to be back at whatever value, we're going to basically take off any extra bits that we had leading up to 16. So we just have to subtract that remainder. Okay, now the final touch on the end is you need an area effect cloud. So this area effect cloud is going to be temporary so that we can move to the location pretty quickly. So we summon an area effect cloud and we give it a tag of chunk align, and then we're going to execute store result entity at e tag equals chunk align limit equals 1, because you can only do it to one at a time, and we're going to save its x position to and we need to make it a double with a scale of 1. So whatever the answer is after we subtract, we're going to take that number and put it on the x position of this chunk align, and we can add type equals area effect cloud to make it a faster command. So we need 2 of these, 1 for x, and again 1 for z. So this is a pretty common method that you see in a lot of commands. You start by taking some data from something, you do some math to the data, and then you put the data back on that something. And you can also cut down on command count by putting the operation right here instead of doing a data get. So if I do this, we need one more thing. We need to do execute at e tag equals chunk align run set block diamond block. And once we do that, we can kill at e tag equals chunk align. You don't need to kill it though. I could just leave it like this. It will die after the next tick. So you could want to implement that. I don't know. So now if we play chunk align, then we're going to get this block here. So we can debug. Scoreboard sidebar chords. So what happened is probably we didn't get any values. So let's just go with this command here. So we can run line by line to figure out what might have been the problem. So we got 20. 20 goes to hashtag x. Oh, there is no 16 constant. That's our problem. So we're going to create a scoreboard with a list of constants. Scoreboard objectives, add constant, and then scoreboard players set hashtag 16 constant 16. And this is another popular method that I use and a lot of people use, where you have a scoreboard called a constant and you save a bunch of fake players that are invisible to have specific values so that you can do math on constants. So let's go ahead and run that one more time. And now, boom, diamond block right in the corner of the chunk. So that is our chunk align function. It's probably as best as it gets. I don't know. Anyway, and then also keep in mind that the Y level is whatever it is. So we will come back to that in a second. So next we just need really one more function, and that is going to be what to do at these chunks. So instead of setting a block to diamond block, what we're going to do is we're going to go, we're going to kill it because I don't want it, if we do this thing multiple times per tick, you're going to get some ambiguity. And we're going to add type equals area effect cloud. Okay, so always try and make it as efficient as possible. So we are actually going to fill wherever you're at, but at coordinate 0 at the very bottom floor, and then 15 in front, 0 and 15 in front, and we are going to use some kind of custom block. What block are we going to use? Pick your favorite. I'm just going to go with yellow wool. So what this will do is it'll create a floor of yellow wool, okay? And then what you're going to want to do now is that yellow wool is going to tell you where you've already checked. So let's go ahead and break this into a separate function because I want to do multiple things there. So s::set chunk. Okay, so now we have another function. This function is going to be called set chunk. All right, so set chunk is going to put this wool, and now you're just going to do whatever you want to do in that chunk. So there is a library of things I've made that can help you do this very efficiently, very quickly. Okay, so I have two data packs that are going to be useful here. This one is the RNG data pack, and what we're going to do is we're going to include it here. And then we also have, and I have it linked in the, I have a video on RNG and it has this in the description. And then we also have find biome. Okay, so if we go into here and we go to tags and we go to functions and we go to load, it needs find biome. Okay, so these are both going to be the same. So we just need to add these to our load so that when we load it, everything is at the same time. So you just do comma, find biome, init, comma, RNG, init, just like that. So now we're going to have an RNG function. This is cool. So what we can do is we can do scoreboard players set in math 0. Scoreboard players set in 1 math 2. Or 1, I'll do a 50-50. Then function RNG range. I believe that's the namespace that I have listed. Range LCG. That's what I call it. This actual range RNG data pack has a bunch of things. You can just chop them and call and just have the LCG because that's the best one. But anyways, so we can do execute if score out math. So out is going to be the output. It's going to be a random number between 0 and 1. So out math matches 1. So we'll just do something if it's 1. And we're going to do position. And we're going to go 15 and 15. No, we're going to go to the middle. So 7, 7. And we're going to go to block 6. Run summon pig. So this will just summon a pig at a 50% chance in every single chunk that you check that is aligned with the corner. Now we just have one more thing to do, and that is to create a system to load these chunks. So for now, we're just going to do execute as at s run function. You don't even need the at s really. s::chunk line. Now we just need one more thing. If block 0, unless block yellow wool. Okay, so what this system does is it only plays chunk align if you are standing on yellow wool. If you're standing on yellow wool, it aligns to the chunk. Then it sets the chunk and it will say set chunk. So I can prove that it's not spamming. And this is part of the efficiency part. We have one constantly running command. And if you enter a new chunk, it does a /fill. And there's a little lag. You see that little lag there? There is a little lag. That's probably mainly due to the lighting update because we are in a void world. But you can see it spawned a pig here. And when I go over here, ooh, it spawned a pig too. And I go over here, it didn't spawn a pig. So you can see the RNG going along there. Obviously, you don't want to update a chunk when the player enters it. So you need to create some feelers. You need to create some testing points. So you have to add positioned, and now this is where you add your little feelers, your testing points, whatever you want to call them. So you create kind of a grid of these checks. So instead, we're going to just do this, and we're going to copy all this, but we're going to do run function s : check grid. Okay, and this is going to create a grid. I don't need you anymore. Oh, and I didn't use the find biome. So you can also do slash function find biome locate scoreboard objectives at the play sidebar. Wait, what does find biome? Oh yeah, there was a bug in this. You have to do scoreboard objectives add biome dummy scoreboard objectives at the play sidebar biome find biome. Yeah, so it thinks I'm in the ocean. But that's just, and it also has all these tell-all things, but you can get rid of them and mess with that. Obviously, this is going to change once we enter an actual overworld. So we're just going to play this function anyway, because who cares? It'll be cool. It'll tell us what biome it's in. But anyways, so let's go ahead and set up these, what I would call them feelers or something, a grid of checking. So we go back into S, we go into the actual S subs category, and we do check grid. So what you want to do is you want to check not the chunk they're in, but every chunk like in front of them. And like, so I don't want to check this chunk. I want to check maybe like 4 chunks out. And this will work if you, it's hard to explain. When you first enter an area or when you TP to a new area, this could cause a lot of bugs, or it could be laggy. There's 2 possible situations. We're just going to go with a small grid, but you can create a much bigger grid at the cost of performance. You can also make the grid a ring instead of a grid, so I can check every chunk except for the chunk I'm in. Now, what this will do is if you TP, then you'll have a weird thing of the chunk you're in has not been loaded, so when you leave the chunk, it will get loaded right afterwards, which you can come up with some situations where you double check these other spots. But yeah, you can either make the grid of checking very big, or you can make it a ring, but then suffer the consequence of TP bugging things. But anyway, so execute positioned, and we're going to check 16 blocks that way. Unless block yellow will run function s chunk align. Okay, so we're just gonna have a bunch of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1 here, 1 in the positive 16, 1 in the negative 16, 1 in the positive 16 on the other, 1 in the negative 16 on the other, 1 in both positive 16s, 1 in a positive and a negative, 1 in a both negative, and 1 in a negative and a positive. Gosh, I'm choking up. All right, so there you go. That'll give you 9 chunks it checks, and it'll just fly around. One additional view thing, if you just are some kind of fanatic, is you can actually make this dependent on, we're going to make this so that we get a checkered grid, because checkered grids are spicy. So we're going to go with 2 and 2. This is a cool trick. So you can do, now that you don't care about the scores, you can do execute. How do I say this? So you do scoreboard, players, operation, x, chord, % equals, hashtag 32, constant. Yeah, okay. So you basically want to see if you're in an odd or even chunk, and you can do that by seeing if you do a modulo of 32, if you're in a chunk with a 0 or a 32, or a 64, then it'll return what'll be left on the X is going to be a 0. But if you're in a 16 or you're in a 48 or you're in a 96, then what you're going to get back is going to be 16. So you do this and then you say, and then you do this to the Z. Okay. So then execute if score X chord matches 1, if score Z chord matches 1. So if they are both 1s, then run fill. I'll fill the block above it, but you could fill the block with green wool and then have a block tag to check for yellow and green wool at the same time. I'm just going to do the one above it because we're just doing visuals here. So let's go ahead and do this. What is wrong with this? Oh, there's no space. So what this will do is if you're on a chunk, if you're on a chunk that is a multiple of 16, I'm still trying to work this logic out. So yeah, be careful of that. It's still checking my chunk that I'm in. That's the thing. So it's still aligning to my chunk repetitively. So I have to summon area effect cloud tags check chunk. I have to do area effect clouds all over these and then executed those guys. You could also alternatively have a chunk align, but then have like one for each grid coordinate. This would be more efficient. And those chunk aligns automatically take the player's coordinates and add whatever value they're at to them. So it would take my value and add 16 to it. You can use that as more efficient, but I'm doing what's quicker to show you guys. So then you can do execute as at e tag equals chunk, check chunk, run function s chunk align, kill at e tag equals check chunk, and there you go. So we can go out and you can see it will load in those coordinates, those quadrants. And then also let's go ahead and do, okay, thank you. That's a little better. It's closer to what I want. Yeah, so now we just have to do probably these on the same line as I said before. And let's go with lime wool. And let's reload. And that's giving us almost the right pattern. We just need to say if they're both 1 or if they're both 0. So if they're both even or they're both odd, that's really all you're checking out. So if we do this, there you go. You get your checker grid. Thank God. All right, cool. So there we go. It is a checker grid spawning chunk detector doing random things at each chunk with a little bit of lag when it spawns things in. And it does the feelers of a 3x3. I think that is basically where I'll end this one. In terms of you guys determining what to do, that's all down here. You don't need these extra stuff up here unless you really like the look of it. Then also, so down here, what you would do is you would say, like, if you're within one of these biomes, play a subfunction. In that subfunction, you run another RNG. You run the RNG. And then if the RNG is a certain value, then spawn a structure using a structure block. You can do /set block, structure block with a specific structure name in it, and you can force that thing to load. Or you could clone from one area to another. I was really just showing you guys how to do a chunk loader, a random structure loader. This is the core. This is basically 99% of what you need, and the rest is you making those structures and coming up with some kind of reasonable spawn rate. But anyways, guys, if you thought this was useful, go ahead and leave a like. Tell me something else you want to see. Other than that, thanks for watching, and I'll see you in the next one. Peace.